Hello everyone, greetings from the power outage. So one of the advantages of the things that of the tools that we've been talking about in i211 so far is that you can really, once you have everything stored in a GitHub repository, it is pretty easy to just set everything back up on a new machine. So if things look a little bit different today, that's because I'm coming to you live from a Chromebook right here. But nevertheless, I have reset up all my directories, so I still have an i211, and I've recloned my Hazel i211 starter. We still have access to Git. My Python 3 version is, I think, very slightly different, and code, I think, might be pretty much the same. But for the most part, pretty much everything is exactly the way it will be. So if you want to think of this as one other advantage of using some of these tools, it's kind of nice because if something catastrophic happens, like Bloomington loses power for 24 hours, it's pretty easy to get back up and running on a different device. So today we want to talk about structured data, where structured data is kind of everything beyond the very simple structures we talked about last time. So I'll work inside of a VS Code integrated terminal for a little bit. Let me cd into my notes directory. Let's just kind of keep with the pattern. So let me go ahead and create lesson07.py. See if I can open up lesson07.py. There we go. Okay. And today we're pretty much going to be working with CSV files. So maybe the first thing I'll do is I'll import a CSV. Maybe I'll create a quick file just so I can demonstrate with, or actually, let's see what's inside of sumfile.txt. Yeah, I guess there's nothing in here at the moment. Let me fix that. So let's reopen sumfile.txt. Let's maybe put A, B, C, D, D, E, F, 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 G inside of here. So last time we were talking about this world of simple files where we could just open up sum-file.txt in read mode as fh for a file handler, and let's just see what happens if we print the result of reading that file. So if we run Python 3 lesson07.py, yep, we pretty much just see there's the actual string representation. Alternatively, if we split those on the lines, so .read.split lines, open close parenthesis, what we should see on the other end of it is that now we will split this series of alphabetical numbers into a list of strings, which is exactly what we see. So the name for this is the idea that there is some structure underlying the actual data. Last time we were thinking about data simply as these strings or these list of strings. But the direction we want to now think of is when we have slightly more complex things that we need to represent. So maybe if we had something like this, where our data was containing some file.txt, so the running story we have is that if our data is something like a grocery list, it's probably not too bad if we just want to store milk, cheese, and eggs as a simple list of strings. But unfortunately, the world is not usually as simple as just a very simple list. Usually there's some additional structure that we need to take into account, which our running example here will be this idea that there's some information that is often paired with the data that we're keeping track of. So in addition to keeping track of things like milk, cheese, and eggs, we may need to know something like the aisle number where each of these things occur on. The name for this is tabular data, sometimes called vector data, where we have rows and columns. Each row, which I don't have my normal way for drawing on the screen, so each row of this will be a representation of something in the world, and each column is going to be an attribute of that thing. So if we look at the first row, milk is the name of a thing, and that milk is found on aisle 24. We could even extend these. So since each row represents one item, we might imagine that adding another row to the set of tabular data is kind of like adding another thing. And if we needed to add another property, we could simply add another column to our data. So here, if we wanted to think about the name of each item, like milk occurs on aisle 24, and if we wanted to purchase 1 gallon, that would simply be represented by adding an additional column to this. But one complexity that you'll run into with tabular data is that tabular data, and really any data in general, doesn't really have a fixed way of representing things. There's conventions, but a lot of the time there aren't really hard and fast rules for these sort of things. So if we were saying a second ago that each row in a tabular data set is one item, why might we have represented something where we had a quantity? So maybe I can do it this way. So why would we represent 2 cans right here as opposed to having 2 separate rows inside of the data? Maybe kind of mull this over, think about these 2 things real quick, and then I'll kind of jump to the next section. So there's not really a right or wrong answer to this, because the representation that you choose for your data is oftentimes a design problem. There do tend to be situations that are better or worse in certain scenarios, but there tend not to be strictly correct or incorrect responses. So the way that we phrased it here, both representations can be correct in different scenarios. So one of the ways that you might actually prefer this second one as opposed to the former is that if you were adding some additional information, such as who are you shopping for? So if there were multiple people we shopped for, such as Alice and Bob in this example, it may make sense to say that there are 2 separate cans because we are keeping track of Alice's can of soup and Bob's can of soup. So data representation is really a design decision, and there are other classes that you'll do later in your informatics career that actually address these kind of things. But for today, we want to introduce some of the basic foundations for these, which is how do we represent this tabular data on a computer, how do we work with these tabular data sets in Python, and then how do we pose questions about the tabular data, then implement algorithms to answer them, which is sometimes the role of statistics. Very briefly, tabular data is, well, there's quite a few different ways that you could actually represent it. If you've worked with a program like Excel before, Excel is actually one way of representing these. Unfortunately, though, Excel, if you ever try to look inside of an Excel file, inside of a text file, inside of a text editor, you'll probably see something like this, which is a little bit inconvenient because this is a binary format that must be first decoded before we can actually use it. Excel is a program that handles a lot of this decoding and encoding for us behind the scenes, and the XLSX format is simply an interchange that allows us to exchange these files and send them to one another. The alternative to this is that if instead of having a binary file format, we could use the same plain text formats that we've been using throughout the semester so far. So if we started with this milk, cheese, and eggs example, we could perhaps kind of extend this to the thing that we were working with a second ago. So let's add name, comma, aisle. Milk is on 26, cheese is maybe on 25, eggs is 21. So this opposing view is that instead of a binary format, we have this very simple text file. So this plain text encoding is often so convenient for actually getting things from one person to another that they tend to kind of dominate science and business in a lot of different places as well. The name for this, though, so if we have a first row, so this first row is typically called the heading or the header of the document. Each of these things inside of here, so milk and 26 are each going to be values, cheese and 25 are going to be values, eggs and 21 are going to be values, and since each of the values are separated by a comma, well, computer scientists are very creative, so this is a CSV or a comma separated value file. A little bit of vocabulary there. So by convention, each row from a tabular data set is stored one line on each line of a file, and each column is separated or delimited by a character between each value. So the common choice for this is the CSV, making this a CSV file. So there are quite a few ways that you can use CSVs inside of Python and any programming language. So for today, we are going to focus on just kind of some of the most common ones. So I think last time, as kind of a side note, after we did this whole fh.read.splitlines, I think we implemented something like for-line in fh.read.splitlines. Let's just kind of see what that does real quick. Maybe we'll kind of do some stuff live, sketch out a few ideas as we go. So lesson07.py. Okay, so at the moment, that is just pulling out the names in the aisles. And okay, so let me kind of sketch this out a little bit further. So what if I did want to do like this manual parsing way? So maybe I could say like the rows of the data is initialized as an empty list, and maybe I say like rows.append line.split on the comma. Okay, so line.split is going to return a list of strings, which means that rows is going to be a list of strings, which now means if I print it out, I should see something kind of like a list of strings shown in the terminal. And that's pretty much what we see. So this is one way to think about CSVs, but it's a little bit manual. It's also a little bit error prone. I tend to really like things when I kind of have these canned expressions that I can use over and over again. So reading CSVs in Python, the way that we'll show today is kind of the most common way. You can skim kind of how we build up to this. So we initialize the dictionary reader. Then you can eventually think of us having this thing where we initialize the dictionary reader. We iterate over all of its rows because it is an iterable object. So I'll kind of slot these in here real quick, kind of visualize what these look like. Let me adjust my variables. So CSV file doesn't exist. That's okay. We just called it file handler earlier. We'll fix that real quick. So now what we should see is more or less the same, except whereas previously we saw this list of lists of strings, now we should run into a list of dictionary representation. So let me do the up arrow, try that again. Yeah, notice how we get something very slightly different, quite a bit different here. Each time that we are iterating, let me see if I can kind of move that down a little bit. We see the terminal and this at the same time. So now each time we are iterating through this line, these values inside of the dictreader object and print out each row, each of these individual things are going to be a dictionary mapping strings to other strings. So maybe if you were interested in just like the aisle numbers, you could do something like print out the aisle contained inside of each row. And that should print out 26, 25, 21 because we are accessing the aisle key, the value associated with the aisle key inside of each of these intermediate dictionaries. Maybe if this was really important to you, you could say even like the aisles is an empty list. You could iterate over for each row. Maybe you could say like aisles dot append row of aisle. Something like that. Maybe print out the aisles once you're done, and that should print out a list of strings which contains the aisle numbers. Okay, so we're just kind of sketching, but once you're kind of familiar with this thing and you play around with it, you'll probably just end up doing these two lines of code over and over again. So actually, I probably didn't even need to copy that here. Let's just kind of say that what is the final set of data that we need? Well, we knew from earlier that we need to initialize this reader, and then we needed to iterate over each row in the reader, maybe pulling out something like for row in reader. Maybe we could say that the data is initialized as an empty list for row in reader. We do data.append row. Just confirm that data is a list of dictionaries right here. Let's just confirm that in the terminal real quick. There we go. Yep, that's pretty much what we expected to see. So you could actually rewrite this entire like 1, 2, 3, 4 lines of code down into a much simpler expression where we take out that list, we slot in the csv.dictreader, but before that we wrap that into a list, which means the data that the list object, the list initialization, will consume the csv.dictreader in order to convert that into a list of dictionaries at the end, which gives us the exact same result. Okay, so there's a few things that can kind of trip you up along the way, which we've mentioned along here, but as long as you're vaguely aware that these two lines of code will get you a list of dictionaries, you're probably going to be pretty good. Let's talk about the opposite now. So if you want to then write those things back to a CSV, it's pretty much going to be the same approach that we saw earlier, where last time we saw that we could open up files. So with open some file, well, we're doing txt for a moment, CSV, txt, they are both plain text representations, so you can do pretty much either way. So last time we opened up a file in write mode. This time we are going to initialize. So we're going to initialize a writer object as a csv.dictWriter. I think inside of this we have to pass along the CSV file pointer, and then I think we can say field names. So let me just kind of confirm, what are the two field names? Oh, okay, well, name and aisle is the first line of the CSV. So let me copy those to my clipboard. Let me say field names, maybe minimize the sidebar. So field names is going to take some kind of list, a list of strings rather. So we need to pass in the name and the aisle, which are the two columns. Okay, so now we are going to say something like writer dot, let me try to think through my steps real quick, try to remember. So the very first step is we initialize a writer object. We probably want to write the header information. And the very last step is going to be writer.write rows. So according to my type signature, rows dict is an iterable mapping strings. Okay, so maybe we don't quite know what an iterable mapping strings is, but the simple answer is that this data parameter, this data variable we have up here, we said is a list of dictionaries mapping strings to strings, which means that we can pass along data into here, and that should write out the exact same information back to the file. So now what should happen is it's going to look like not much happens. Let's just kind of put this on the clipboard just in case something crazy happens. But 1, 2, 3, 4 files, 4 lines, name, aisle, milk, cheese, eggs. Let's see what happens to sumfile.txt when we rerun this code. So Python 3 lesson07.py. Okay, so nothing happened, but that's kind of a good thing. Because, remember, we opened this file, we read it into a Python data structure, and then we opened the file back up, we initialized this dictionary, and we just kind of wrote all the same information back out. So this right here is a read step. This thing down here is the write step. So here's a question for the audience. What would happen if we modified the data between reading and writing? And maybe I'll even say another question, which is how. Try to think about that for a second. How might we add a new column to this sumfile.txt? Or excuse me, how might we add a new row to the sumfile.txt? Okay, so maybe you have an idea so far. I'm going to implement one idea, which is, well, it's a list, so we can append a new item into it. What do we need to append into it? Well, we need to pass in a dictionary, and that dictionary needs to contain a name, and it needs to contain an aisle number, because that is the information that each row contains. Therefore, adding a new row means adding a new dictionary. So what if we say butter is on line in aisle 10? What happens when we run the code now? Well, we think that we are going to add a new row to the very end of it. So let's see what happens when I run the code. Python 3 lesson7.py. Sure enough, butter 10. And if we run this multiple times, so 1, 2, 3, we now have butter, 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 butter. Okay. So writing CSVs, again, there are quite a few ways that you can actually use these various CSV writers and readers, but for the most part, as long as you're aware that a template for how you will write your files looks something like that, you can probably pretty much figure out the rest of them. So very generally, let's do one other step, which is one of our big takeaways from the last section was that we usually want to think about pulling these things into individual functions. So if we have a read step, let's rewrite this into a function that maybe says like define a function called read_groceries. And maybe we have another write function, so write groceries out. Okay, so we sort of have something, but now that we've refactored these into functions, notice that this data variable is kind of grayed out, so we probably need to return it from the function at the end. So if we return data and maybe modify our type signature such that we say that this is expected to return a list of dictionaries mapping strings to strings. Similar for this one, well, we don't have a variable called data right here, which is why we have the red squiggly underlines. So that means we probably need to pass it into the function. And if we assume that this thing is a list of dictionaries mapping strings to strings, then this will not return anything at the end, simply because it opens the file and writes it back out. So we will say that it returns none. So where did we end up with this? Let's add an if dunder name equals main. Then we can say that groceries equals read_groceries. And if we say write groceries out and we pass the groceries list of dictionaries into it, then we should be back at that same state where we can open files, pass them around, and write them back. Looks like nothing crashed, so we're probably on the right track. Okay. So that's pretty much the big takeaways that I want you to have with these things. And the nice thing now, well, we kind of mentioned a few of these things earlier. Using tabular data and then analyzing tabular data from within Python is pretty much going to be exactly the same as all of the things that we've done so far. If you want to add a new row, well, we saw a moment ago that that's just appending to a list. What if you wanted to get some information out of it? Well, again, we kind of saw this earlier. If you want to iterate through all of the rows, getting each of the aisles out, that's a matter of doing a iteration over all of the rows in the file, pulling out a piece of information from each of them. So all of your previous knowledge for like how you work with lists, how you iterate through lists, and how you pull information out of dictionaries is still relevant to data analysis within Python. So we have some review notes down here on sorted versus sorting. I think for the most part, these are going to be good review concepts that can be really helpful both in today's implementation practice problems and on the upcoming practice set. But for the most part, I'll kind of just slot these in here and let you review those on your own time. So for the remainder of this, I do want to get into the practice problems, so you have an opportunity to work along with me or to kind of work on these by yourself and then review some of my stuff at the end. So this would be a good time to pause the video, try to work through some of these practice problems on your own time. And 3, 2, 1. Okay, so now if you're hearing the sound of my voice, I'm going to assume that you want some kind of real-time workflow with some of the practice problems. So I pretty much have everything open right here. Let me just kind of work through a couple of these things. What happens inside of my git status? Okay, so I have a couple extra changes. Let me go ahead and add both of these. Git status to stage both of those. Let's make a commit and say git commit-m, add some notes for day 7. Okay, cool. So we've made a commit. Let me cd. So I'm currently inside of my notes inside my i211 starter. So I will cd down a directory. And now everything's pretty much here. Maybe I can confirm to run the tests and everything looks good at the moment. So I'm probably ready to start working on rps.py. So my first recommendation is that we want to convert our gamehistory.txt from this kind of ad hoc txt representation into something that's a little bit more explicit about the fact that it's a CSV file. Okay, so we have a couple steps. The first one is to rename. So I think I vaguely know what some of these are. Ooh, and actually, since I cloned to a new machine, and remember, inside of the git ignore, the very first line is gamehistory.txt, so I actually don't have a gamehistory.txt yet. But that's okay. That's very easy to fix. So if I do python 3 rps.py, if I choose scissors, oh, I won. Awesome. And the act of playing the game means that I now have a gamehistory.txt file. Okay, cool. Let's do git status real quick. Okay, so now what do I want to do next? I'm actually going to do step 2. Okay, so rename gamehistory to gamehistory.csv. Okay, so let's do move gamehistory.txt to game-history.csv. What's the next step? Git status. Okay, well that added gamehistory.csv to my untracked files. So that means that I now need to add that to my git ignore. So let's do Control P, open up git ignore. Let's add game-history.csv inside of here. Close out of that. This would be a good time to say git status again. Yep, because we've modified the git ignore. Add a header row to the file, human, computer, and winner. Ooh, interesting. So that's new. If we do game, so if we do open up gamehistory.csv, where is it at? There it is. So we now need to add a header row to this, which it says we should do computer, oh no, human, let's see, human, then computer, then winner. Okay, so there's a column that we don't have right here. And actually, quick side note, notice how mine are actually a little bit easy to tell which one is which. That's because I have an extension called, I think, Rainbow CSV. Yeah, Rainbow CSV installed, which kind of just makes it a little bit more convenient to see what some of those look like. Okay, so back to gamehistory.csv, back to my rps.py. Okay, so the winner in this case was human, H-U-M-A-N. Okay, and fill in the values for the winner column. Yeah, okay, so it looks like we should have something pretty similar to this. So it looks like I'm done with this problem. Let's say git status. Yep, we have added some stuff to the git ignore, so I'll actually do that in 2 steps. Let's go ahead and add git ignore, git commit-m, add CSV file to git ignore. Okay. I don't think I made any notable changes to the... Yeah, it looks like there was a spacing problem, so I'm not going to worry about the Python stuff just yet. Maybe if you want to be real pedantic, though, the tests do still pass. Okay, so what's the next step? Write a function to determine whether the human won, the computer won, or there was a tie. Ah, okay. So since the CSV structure has a winner column, let's write a function that returns the human, computer, or tie for any pair of inputs. Okay, so this would be a good one to do. Let's kind of jump down because I think I have some file IO stuff up here. Feels like this is kind of a either after the validation, after beats, after getting, yeah, maybe right here. This just kind of feels like the right place for it. Decide winner. Okay, so I think I actually have this already, but let me jump down to like the main block. Yeah, because I already have something like this, which is currently inside of here. So maybe I'll cut this out, put that on my clipboard, jump back up to that function that I was writing, which I think was called determine winner. Yeah, decide winner. Okay, I will remove the ellipsis, paste that in here, fix my indentation a tiny bit. Okay, so here's the thing. Now instead of printing something, so instead of returning none, we now want to return a string. So I think what we want is, write a function returning human, computer, or tie for any pair of inputs. Okay, so instead of printing it to tie, or actually maybe in addition to printing it to tie, let me go ahead and return tie if the human beats computer. Yeah, sure, we will print out that the human won, and let's return human. Otherwise, let's return computer. And actually, we don't really need this else statement anymore, so I'm going to remove it and drop that out. Actually, I think I do like that, having that in. There's not really a right or wrong answer for some of these things. It just kind of feels what kind of feels best. And while I'm at it, maybe I'll add some tests for this one too. So test rps.py, just to confirm that that's kind of meeting my expectations. So what does a decide winner look like? Let's jump into this and say maybe like validate winner, loser. Sure, why not? So class, let's see, class validate winner, loser, tie is a test case. And sure, let's just throw in one like test that human is winner when human, when rock beats scissors. That seems like a reasonable test to do. Self.assert equal rps.decide winner when the human chose rock, the computer chose scissors, and the resulting string should be human. Python 3 test submission, test rps.py, ran 9 tests. That looks good. Okay. So I think we actually did that pretty quickly. So let's just do a git status real quick. Oh, actually, hold on. Before I do that, let me play the game one more time. Let's do rps.py. Let's choose rock. Okay, interesting. So a couple things are going on that I want you to notice. We're kind of in this middle ground at the moment where things are a little bit broken. So notice that I'm still outputting a gamehistory.txt, but I'm also outputting a gamehistory.csv, and it doesn't look like the winner was currently chosen. So if I do Python 3 rps.py rock, yeah, it doesn't show me who won anymore. That's because I cut the information out. So let's jump back down to the main block, go down. Ah, that's right. So now we have to decide the winner based on the human and computer information. Okay, cool. Now let's try running the game again. I choose rock. Yep, computer chose paper. It still shows me that information about the computer winning. Okay, so git status. So I don't really want to make a commit just yet because our code is kind of in this half-broken state at the moment. So let's kind of move on because step 3 is going to be all about rewriting the loading and save steps using the CSV. Yeah, okay. So now that we have CSV, we want to rewrite those load game history and save game history to actually use a CSV representation. Also of note, we no longer will need this parse game history function, because recall, that was pretty much just doing what the CSV stuff is now going to do for us. And we also want to account for the idea that we need to fix the append step when we update the game history. Okay, I think I've got some good ideas for what to do next. And this is also one of those times to remember that my stuff is a little bit broken at the moment. Okay, so step one, let's import the CSV module because we're going to need that. I'm going to remove this kind of useless comment about file I/O. Okay, now instead of loading the game history, we want to deal with that CSV file. So we have a gamehistory.csv, which is going to contain all the same information. Okay, so instead of gamehistory.txt, let's kind of do this one line at a time. So change to CSV. We still want to do read mode. I'm going to be a little pedantic. Instead of FH, I'm going to call this a CSV file. It's a variable. It doesn't technically matter, but I kind of like it this way. And instead of returning fh.read, what was that trick we saw? What was that trick that was like 2 lines of code that would allow us to really easily open up a file? CSV.dictReader, that's right. Okay, CSV.dictReader, and we know that this list of CSV.dictReader is a very easy way to pull this out. Okay, so let's return CSV.dictReader, give it the CSV as an input, and wrap that whole thing in a list constructor. Okay, cool. So now we should have a way to load the game history. How might we test this? Ooh, actually notice there's a bug in my code. Try to spot it real quick. Okay, do you see it? Yeah, okay, so right here we're referring to gamehistory.txt here. Here we're referring to gamehistory.csv. Okay, good thing we caught that. Okay, let's fix that real quick. Okay, so we're kind of in this manual testing mode at the moment. So maybe we should see if we can actually run the code now. So let's open up a terminal. Let's see what happens when we do python 3 rps.py. Okay, I'm going to choose paper, and we crash. Interesting. So we get an attribute error. List object has no attribute split lines. Why did that happen? Well, it looks like, and I hope you see this okay, I've tried to highlight line 17. Let's open line 17 in the editor. Yeah, okay, well, now we are trying to split lines this thing. Okay, so a lot of assumptions about our code just changed. We're no longer returning a string from load game history. Now we are returning that list of dictionaries mapping strings to strings that we talked about earlier with CSV files. So we don't actually need this parse game history anymore, which I think we've also mentioned. Now in load game history, let's jump to that definition. Yeah, okay, so now we need to update some of this stuff. So we no longer need the parse game history because CSV is parsing it for us. So let's modify that. So now we say the history is equal to loading the game history. Ooh, we're going to have to fix this line in a second because we're going to need to modify that implementation. And we are also going to have to modify the save game history. I'm going to do that right now. So Control F, same game history, jump up to the definition. We said earlier we're going to be working with the gamehistory.csv. Let's replace that right there. And now, okay, we no longer have a lists of strings. We now have a list of dictionaries mapping strings to strings, but we will still return none. Okay, we don't really want any of this stuff anymore. So now we want to do that. Oh, hold on. What was that thing? What was that thing that we were trying to do where we were writing CSV files? Okay, let's go back over here. Let's maybe scroll down. Okay, that's right. We know how to write CSVs in Python. It's 4 lines of code. It looks kind of like this. Okay, if you don't remember it, that's okay. You can probably work through it and based on what's in there. Let's just remind ourselves. We first initialize a dict_writer object. What do we need it to point to? Well, it needs to know about the file we are writing to, which I'll be real pedantic, change that to say that is a CSV file that we've opened up. We also need to pass in the field names. What are the field names? Well, the field names are the header column. So I'm going to copy that. Remember that the field name should be a list of strings. So I'm going to paste that inside of a list. Then I'm going to separate out all the commas. Okay, so now we have a list containing 3 things instead of a list containing 1 giant string. Okay, let's do writer.write header, and then let's do writer.write rows with the history. Okay, 4 lines of code. We should have game histories working. Okay, let's jump back down because there is something in the main block that we said that we still had to fix, or the main function that we said we still had to fix. Yeah, okay, so here's the last part. We need to update the history. So instead of passing in this thing right here, which is a list of strings, we need to modify this to pass in a list of dictionaries. What is the dictionary we pass in? What are the keys of it is the first question. So we know it's going to be something to something, and we think that there's going to be one, two, three of those things. Let's fix indentation real quick. Okay, what are the keys inside of the history? Well, I don't quite remember, but that's okay. I can look in the file. Oh, that's right. Human, computer, winner. Okay. Human, computer, and winner. Okay, what are the values those things take on? Okay, well, let's take that thing out. Let's pass in the string, human, defined on line 83, the computer, defined on line 84, and the winner. Uh-oh. What is the winner? Oh, wait a minute. That's right. The winner is right here. Let's cut that out. Let's put that inside of here. So we will decide the winner, and since that returns a string, it will be placed inside of the dictionary when that runs. Okay, I think we might have this. So remember that we are going to be kind of manually testing. So let's see what happens now when we run the code. And maybe as a quick before and after, let me cat out the game history.csv. Okay, we have only one entry where it says human, computer, winner, scissors, paper, human. I expect that now when we run the code, so python 3 rps.py, I expect to see two lines set based on my choice and the winner. So let's see if I choose paper this time. Okay, computer chose scissors, and computer won. So that should be reflected in gamehistory.csv. Excellent. There we go. Human won, then computer won. I'm pretty confident in this, so I think we're very close. Let's go ahead and run the tests. Oh, excuse me. Let me try that again. Let me run the tests. Test rps.py. Oh no, there was an error in the test. Attribute error. RPS has no attribute parse game history. Okay, so this is one of those interesting times where we wrote a test, but we maybe didn't necessarily need it yet. So you remember a moment ago, we no longer needed that parse game history, so we removed it. Well, I'm going to have to now modify my tests to remove this thing that is no longer necessary. Okay, now what happens when we run the tests? Okay, looks like our expectations are still correct with respect to everything else. Okay, so I think we're pretty good now on all of this. Let's do another quick cleanup, get status, see if there is anything else that's changed. Okay, I'm going to remove this gamehistory.txt file because it shouldn't be relevant anymore. Let's do a get status. Let's just confirm. Was there anything else inside of here that we needed to do? Nope, I think we pretty much got it. Cool. So let's go ahead and git add everything. Let's say git status to confirm those are in our staging area. Let's make a commit right here and say add or rewrite to use CSV instead of TXT. Cool. Okay. Working tree clean. Very good. Next problem. Compute the number of wins and the number of ties. Okay. So this problem says that let's work toward building a scoreboard for how many times the human won, the computer won, or the game resulted in a tie. A good first step would be to write a function that takes a list of final states and counts how many times each result occurred. Fun. Okay, so some game outcomes. It looks like this is going to be a pure function that takes a list. Oops, I keep doing that. Try that again. Some game outcomes. Okay. So it looks like this is going to be a pure function that returns a dictionary mapping strings to integers. So there is actually a name for this called a counter. So maybe I'll kind of show two ways to do that toward the end. I'll decide later. Okay, so maybe after decide winner, this feels like kind of a right place. So let's Control V to paste that in. Okay, so sum the game outcomes. So it says that the game outcomes is going to be a list of strings, which makes me think that we're just going to be working. So just work with the winner column of the CSV. It's not exactly the way we're going to implement it, but it's basically the same idea. Yeah, and sure enough, if we look at some of the examples, if we pass in human and computer, which should result in something where we have human 1, computer 1 ties 0. Or if we only ever see ties, we should still see human and computer information, but we should see 4 ties. Okay, so this kind of tells me that we might want to initialize. So let me actually kind of copy one of these outputs. Okay, and back over here, let's actually initialize like totals. So totals equals this dictionary, but let's initialize it so that the human is 0, the computer is 0, and the ties is 0. Okay, so this is very close. So we could return the totals already, and we actually have pretty much the function signature we need, because this is a dictionary mapping. This thing right here is a dictionary mapping strings to integers. But we probably need to do something with this game outcomes that we're not currently using. So, well, we said earlier that it could just be it will just be a list of strings. And I'm going to assume that we have good data. So I think all we really need to do is iterate over game outcomes. So let's say for game in game outcomes, let's update the totals. So on the first iteration, let's imagine that game is the string human. So that means that totals of this type, oh, excuse me, this isn't a game. A better word for this would be like this isn't a game, it's like an outcome. Yeah, so for each outcome in the game outcomes, the total is incremented by 1. So plus equals 1, which means that at the very end, if we see something like tie, we will update the tie value. We will update the tie value a second time, then a third time, which means this should return something kind of like what we expect. Maybe before I run this, I will write a set of tests just to maybe confirm that. In fact, I can probably just copy and paste these from right here, and because these are the inputs and outputs. So let me just jump down to like, I don't know, line 35. Let's say class, this is a, what are we doing here? Scoreboard validation test case. Def test, let's see, test some outcomes 1. I'm being very creative with test names right here. Okay, so what are we asserting? Well, okay, we are asserting that 2 things are equal to one another. What are we asserting is equal? Well, this thing right here, we are asserting that it will be the same as this thing right here. Let's see, no longer need that. Let's copy this entire test, paste it down there. Okay, so now instead of sum outcomes 1, let's just sum outcomes 2. Now we're going to assert equal 4 ties in a row. Cut this thing out, drop it inside of here. And what are we asserting it's equal to? Well, we're asserting that it's equal to this thing. Paste that right here. Finally, we don't have sum game outcomes, but we do have rps.sum outcomes, so that should fix the very last part. Okay, let's see what happens when we do Python 3 test rps.py. Cool, ran 10 tests, look like all those tests were okay. So I'm pretty confident in this implementation. Maybe I'll do a tiny bit of cleanup, just make my code a little bit more condensed. Let's do get status. Let's go ahead and do maybe a manual test where we do rps.py. I'll choose scissors. Cool, it's a tie. Very good. So I think this is probably okay. Let's go ahead and do a commit. So let's do get status. Let's add everything into my staging area. Get status to confirm it is in my staging area by turning from red to green. Let's do get commit-m implement. What function do we implement? Sum game outcomes. Close those out. Very good. Next up, let's actually print out that scoreboard. Okay, so now that we have a dictionary, let's make that dictionary a little bit easier to read, where we can see human, then computer, then tie, all kind of stacked on top of each other like this. Okay, so let's pull out that print scoreboard. Notice that this function is going to return none, so this isn't technically a pure function that's really easy to test. But that's not a huge deal. So I know that this is going to take, so let's just kind of do some quick matching. So this function right here returns a dictionary mapping strings to integers. The print scoreboard function takes something, which is a dictionary mapping strings to integers. So I'm going to assume, so I will assume, So assume outcomes is well formatted, by which I mean let's assume that outcomes contains everything I expect it to. So I'll implement this like kind of 3 steps. So let's imagine that we have human is just the value associated with the outcomes human key. Let's paste that 3 times. So we have the number of humans, we have the number of computer, and we have the number of ties. So how many times did human win? How many times was there a tie? How many times did something else happen? Let's see, what do we want this to look like again? Well, I'm just going to kind of pull this out, see if I can maybe get the outcome to look a little bit closer to what I expect it to. Let's say something like outcome or scoreboard is equal to a string. Let's do this triple string just so that we have access to all of this stuff. Let's just kind of make it formatted a little bit nicer. I will turn this into an F string, and since I have these variables right here, that means I should just be able to replace the 1 with the variable human, the 1 with the variable computer, and the 0 with the variable tie. Let's see what happens if I just print out scoreboard right here, and maybe I want to see what an example of this would look like. Well, we said a second ago that some game outcomes is pretty much the output or the input to this one. So let's just kind of exit right here, and we'll do some incremental development where we print the score. We call the print scoreboard, which takes a set of outcomes, which is simply the result of calling some game outcomes. Okay, so I bet this should print out 004. Let's see if that's what happens when we do python rps.py. Sure enough, but it looks like it's a little bit weird. So I'm not sure if you can quite tell, but do you see how there's like some indentation inside of it? That's something that I want to fix real quick, just to make it a little bit more normal. So this is kind of a quirk of using these triple double quoted strings. So if I were to remove the 4 spaces from right here and run the code again, that means that there's no longer that extra step. If I were to remove this right here, that should remove the new line at the end. So let's just try that out. And it looks like there's still a new line at the beginning, which is because I have one right there. Okay, that looks a little bit closer to the expected output that I had, to my expectation. So I'm going to do one last fix, which is to remove 2 of these quotes, and I'm also going to just kind of force everything to be on just a single giant line. There's a lot of ways that you could actually do this, but this is probably just my preferred way. While I'm thinking about it, instead of human computer tie like that, I'm just going to rewrite this into human computer tie equals outcomes.values. Just kind of another little preference. There's not really a right or wrong way to do a lot of things in code. It's just kind of ways that you prefer or not. And it looks like we still get the exact same result. So I'm pretty confident in my implementation now that I've manually tested it. So I think the next step, so when this function is complete, print the scoreboard at the end of each game. Okay, so that means we have to jump back down to the main block, the main function definition. And really all I have to do now, since we have updated the history after each iteration, is now we can pull that idea where we said we have to first sum the game outcomes. So we have to get something. There's really a couple steps here. First, one, get the outcomes from the history. Step 2, sum them up. Step 3, print them out. Let's see, so what do we do in that case? Well, we said that this is kind of similar. Let's draw an analogy because this is really similar to that extract the aisles. So what was that thing that we talked about in the documentation or in the book where we were saying extract out the aisles from the grocery list? This is really doing the same thing. So maybe we can kind of pattern match with that solution up here. So I think we said like for row in or aisles, let's just kind of, getting the aisles. So this example where we try to get out the aisles is actually identical to what we're trying to accomplish when we are printing out all of the winners, or when we are extracting the winners from the history. So instead of iterating over each row of a set of groceries, we want to iterate over each row from the history and extract out the winner from that game. So let's implement that. So we can first say something like winners equals the empty list. We can iterate for row in history. We can say winners.append row of the winner value. And that should give the information in a list of dictionaries. Maybe I can just kind of prove that to you real quick. Print out the winners, comment that out. Now I think what should happen is we have the game history.csv, so I think we should see human computer tie, and then a fourth result based on the game that we're about to play. Let's do python3 rps.py. Let's do rock. Yeah, 1, 2, 3, 4, because I won that game just now. So that means that we pretty much have everything here. Instead of printing out the winners, let's slot in that list that we just created. So winners passed in to some game outcomes, which will then be passed into print scoreboard. Let's add the parentheses around that. We no longer need to print the winners. So now we should print the scoreboard out, which means that we should see the scores so far when we play this game. And there we go. Okay, 2, 2, 1. I'm feeling pretty confident in this. I'm going to do one last fix, which notice that winners is simply a list. We're iterating over every row in the list, appending something in. So just because I'm a little bit pedantic, I'm going to rewrite this as a list comprehension. So this is the same as saying row of winner for row in history. Maybe we'll test that manually one more time. Python3 rps.py rock. There we go. Same outcome. Okay, let's do get status, maybe get diff just to confirm that we implement the print scoreboard function, then we extract the winners and print out that scoreboard. Let's do get add, let's do get status, get commit-m, show a scoreboard on each game. Get status. Okay, I'm going to go ahead and push here. And that should pretty much be what we do for today. Notice that there are a couple extra problems here at the end. I'm going to treat these kind of like bonus problems because I really feel like I can't mention CSV files without at least kind of mentioning a little bit of like these kind of fun data science problems that you can think about on the side. But talk to me on Discord or send me a message if you want to talk about these, because I'm going to kind of leave these as an exercise to the reader.